Welcome to the Q&A session 5 from the playlist of properties of matter. And this session is in continuation of the session number 3. So in the session number 3, we have studied about the modulus of elasticity. And so based on what we have studied in the session number 3, I have selected one question for this session, which is written here on this board. So the question here is, the length of a metal wire is L1 when the tension in it is T1 and it is L2 when the tension in it is T2. So what is the original length of the wire? We have to find the original length of the wire. So we know that the Young's modulus of elasticity is equal to the normal stress divided by the longitudinal strain So, in the first case, the length of the metal wire is L1 when the tension in it is T1. So, if let us consider the original length of the wire is L. Let the original length of the wire is equal to L. So, the change in the length of the metal wire when tension is T1. This is equal to L1 minus L. So this is the change in the length when the tension in the metal wire is T1. Similarly, the change in the length when tension is T2. This will be equal to L2 minus L. So this is the change in the length. L1 minus L is the change in the length when the tension in the metal wire is T1, and L2 minus L is the change in the length when the tension in the metal wire is T2. So now I will be using this formula, that is Young's modulus is equal to the normal stress divided by the longitudinal strain. So in the first case, this Y will be equal to, this normal stress will be equal to T1 divided by the area of cross section of the metal wire divided by the longitudinal strain. So the longitudinal strain is basically equal to the change in the length divided by the original length. So in the first case, the change in the length is equal to L1 minus L. So L1 minus L divided by L. Now in the second case, the change in the length is equal to L2 minus L. That is, when the tension is T2, then the change in the length is equal to L2 minus L. And in the second case, the strain will be equal to L2 minus L divided by L, where L is the original length. Now, since in both the cases, the metal wire is the same, so the Young's modulus will remain the same. So I can simply write that Y is equal to T1 divided by A divided by L1 minus L divided by L, and this will be equal to T2 upon A divided by L2 minus L divided by L. So I've got this equation because the metal wire is the same in both the cases, and since the metal wire is the same, therefore the Young's modulus will also remain the same in both the cases. So this is the equation which I have got, that is T1 divided by A divided by L1 minus L divided by L. This is equal to T2 upon A, this divided by L2 minus L divided by L. So this, by solving this equation, we will be able to find the original length of the wire, which is taken as L in this case. So T1 divided by A. So this L will come in the numerator. So this is equal to L divided by A will come in the denominator, and this will be equal to L1 minus L, and this will be equal to T2 into L divided by the area of cross section multiplied by L2 minus L. So this is the equation which I have got, and now by solving this equation we will be able to find the value of L, which is the original length of the wire. So from here this A and L will get cancelled out. So finally what I am getting is T1 divided by L1 minus L. This is equal to T2 divided by L2 minus L. By cross multiplication I will get T1 L2 minus L. This is equal to T1 in bracket L2 minus L. This will be equal to T2 in bracket L1 minus L. So T1 L2 minus T1 into L is equal to T2 L1 minus L T2. So I will be taking the terms containing L on one side of the equations, that is and the other term, that is the other terms will be taken on the other side of the equation. So it implies that T1 L2 minus T2 L1, this will be equal to T1 L minus T2 L. So what I have done is I have taken this T1 L on the right side of this equation, and I have taken this T2 L1 on the left hand side of the equation. So by doing this I have got this equation. So finally from here this L can be taken as common, that is L T1 minus T2. This will be equal to T1 L2 minus T2 L1, or we can say that the original length of the wire will be equal to T1 L2 minus T2 L1 divided by T1 minus T2. So in this question what we have done is, in order to find the original length of the wire, I have simply used the formula of the Young's modulus of elasticity, and since the metal wire was the same in both the cases, so we had got two equations. In the first case, when the wire length was L1 and when the tension in it was T1, and in the second case we have got another equation when the tension when the wire length was L2, when the tension in it was T2. So we have got two equations, and then after equating both these two equations we have got the original length of the wire, which is equal to T1 L2 minus T2 L1 divided by T1 minus T2. So thank you very much for joining this session. In the next session I will be coming up with another different type of a question from the same topic, that is the modulus of elasticity. So till then, have a nice day. Bye.